Hey, what's up, Logic fans? Welcome to our 11th section on quantificational symbolization. We are coming to the end of this chapter, which is 413, but here, our 11th section, 411, and we're going to pause from introducing more symbolic apparatus into our new symbolic system here. And instead, what we're going to do is we're going to focus on some formal properties of relations. These are important, historically well-trodden, apt to come up in a lot of your classes: philosophy, mathematics, computer science, linguistics. They can show up anywhere. They can and do show up everywhere. And so it's worth taking some time to get familiar with them. All right, let's rock. Okay, so what do we mean by formal properties of relations? Well, some relations have certain properties that other relations lack. So let me give you an example of it. So here's a test, okay? My question for you is pretty simple. Can you think of actual relations? Is the mother of, likes, is taller than, is shorter than, is the same color as, okay? Can you think of any kinds of relations that satisfy this description here? They satisfy the description. Everything bears that relation to themselves. Pause now. Okay, so there are lots of relations that satisfy this, but let's just say, for example, that Rxy was x is the same color as y. All right, so if x is the same color as y, notice that everything, no matter what you pick out of your domain, it will satisfy the description it's the same color as itself, right? Even on the empty domain, this holds, right? So this turns out to be true even on the empty domain. So the idea here is that we say that the relation is the same color as this particular relation here, not any other, not is the father of, not is less than. This particular relation here is a reflexive relation because it satisfies this description, okay? So think of this description here as the formal definition of a relation being reflexive. So we would say, for example, a relation R is reflexive if and only if, right, this, okay? So that would be like our formal definition of the relation. It has to be this way. So as we can see here, the particular relation is the same color as is in fact a reflexive relation. Can you give me an example of a relation which is not reflexive, which does not satisfy this description? Pause now. Okay, so fxy, x is taller than y, let's say. That would not be reflexive because it does not hold. So like what you're asking yourself is, okay, here's my relation, is taller than. In order for it to be reflexive, it has to satisfy this description, right? And the question is for everything in my domain, is it the case that it is taller than itself? And the answer to that is no, nothing's taller than itself, in fact, right? And so because this description is not satisfied for the particular relation f, it turns out that f is not reflexive because in order to be reflexive, you have to satisfy this description, okay? So you're thinking about a particular definition, right? And you're thinking about a particular relation, and you're asking yourself whether or not the particular relation that you're thinking about satisfies the description or not. If it does, then we say that the relation has that formal property. This is the formal property. If the relation does not satisfy that description, then it does not have that formal property. Okay, and so what we're going to do today is we're going to discuss a whole bunch of these important historical formal properties of relations. Okay, so let's do an example to make sure we're on the same page here, all right? So let's suppose I've got a domain. It's got three objects in it, A, B, and C, okay? And we're considering the relation Rxy, okay? And these are the 9 possible statements that you can make from A, B, and C, and R. Now, you know, RAA is true, RAB is true, RAC is false, okay? So my question for you is, based on this information, can you determine whether this particular relation here, R, is reflexive or not? Pause now. Okay, hope we've had a chance to pause and think this through, but the relation R here is in fact a reflexive relation. Why? Because it satisfies this description, right? It passes the test, the definitional test of reflexivity. How do I know that? Well, there's three objects, A, B, and C. So I need to check what's going on for RAA, I need to check what's going on for RBB, and I need to check what's going on for RCC, right? And you'll notice that in all of these cases it's true. This one's true, this one's true, and this one is true, right? Because the definition says everything has to bear the relation R to itself, and everything in my domain does. Therefore, this R here is an example of a reflexive relation. Let's try a couple others. So in addition to R, can you tell me whether this relation F is reflexive or not? Can you tell me whether this relation K is reflexive or not? Pause now. Okay, so let's check out what happens for the case of F. Well, A bears the relation to itself, so far so good. B does not, and we can stop right there, right? Because reflexivity says everything has to bear, everything in my domain, no matter what I pick out, it's got to satisfy this description. Well, B doesn't, so this is not a reflexive relation, okay? And it does in fact hold for C, but it just takes the one to break it because definitionally it's about everything in the domain. K is not a reflexive relation because check it out, right? A does not bear the relation K to itself, okay? And that's the basic concept of reflexivity. I want to show you another way of thinking about reflexivity. This is a very helpful sort of pictorial way of visualizing what this definition is saying and what it requires. Okay, so imagine now we've got a domain. Once again, it's got three objects in it, okay? And these three objects, we don't really know what they are, but let's just sort of depict them this way, okay? So I've got these three objects in our definition of reflexivity. Now, in order for a relation R defined on this domain to be reflexive, it has to be the case that every single one of these bears R to itself. So this one's got to bear R to itself, all right? So we'll put an R here like this. So the idea is that the arrow is indicating that A bears the relation R to itself. If I were to draw an arrow like this, what I would be saying is that A bears the relation R to the object B, okay? And if I drew an arrow from B to A with the R, I would be saying B bears the relation R to A, okay? But here what I'm doing is I'm saying that A bears the relation R to itself. So in order for R to be reflexive, you could sort of picture it, you know, it has to be like this, right? Everything in the domain, everything, A, B, and C has to be bearing the relation R to itself. So sometimes visualizing it in this sort of way gives you an idea of like, okay, I see what property we're talking about here for the objects in the domain. And I think it's a helpful way of visualizing things. So I'm going to show you that on occasion in these videos. Okay, let's press on with the topic here. So we're talking about reflexivity. Now, reflexive, a relation is reflexive if and only if everything in the domain bears that relation to itself. But it turns out that reflexivity, or being reflexive, is actually part of a family, you know, a familial network of relations, let's say. So there are actually three relations here that we want to discuss. So reflexivity, or being reflexive, which we just discovered, which we just discussed, and then there's these other two here that go along with it, which are being irreflexive and being non-reflexive. And basically, these cover all logical possibilities. So this covers the logical possibility where everything bears the relation to itself. This covers the logical possibility where everything does not bear the relation to itself, everything in the domain. Okay? And this one is a bit of a special case, and I want to define it for us together. It's basically the in-between case. It's the case where some things in the domain bear the relation to itself, and some things do not. So we're going to define that in the fairly standard way, but we're going to say so at least one time it operates this way, and at least one time it operates that way. So I guess we could think about it this way, right? We could do, okay, so sometimes it's like this, and sometimes it's like this. So we could think about it that way, but of course what we want to do is introduce the existential quantifier. So there's at least one item in the domain, right, that behaves reflexively, and there's at least one item in the domain that behaves irreflexively, Okay, so I'll talk about these in a sec, but let me show you sort of pictorially what's going on with irreflexivity. Everything in the domain is such that it does not bear R to itself. So visualized, it might be like this. So a moment ago we had reflexivity up here, but now we have irreflexivity. So we've got this not here. So everything in the domain has to satisfy this description. So if it's three objects, A has to satisfy the description that it does not bear R to itself. B has to satisfy the description that does not bear R to itself. And C has to satisfy the description that does not bear R to itself. Okay, so no matter what you pick out of the domain, it has to be this way. Okay, everything in the domain has to be this way. All right, now let's think about a case of non-reflexivity. So in the case of non-reflexive, we need at least one item in the domain to be reflexive and at least one item in the domain to not be reflexive. So let's say that we've got A and C both being not reflexive, so at least one of them satisfies this description, namely A and C. But let's suppose we've got B being reflexive, and it would look like this. So you'd have B kind of like this, right? Okay, so if you had a domain like this where A did not bear R to itself, and C did not bear R to itself, but B did, that would satisfy the description of non-reflexivity. Okay, so as you can notice, right, these things, reflexivity, irreflexive, and non-reflexive, they are mutually exclusive and mutually exhaustive. There's one slight exception to that, but they are mutually exclusive and mutually exhaustive, meaning you pick a relation R out of a hat, it's going to satisfy one of these three properties and only one of these three properties. The only exception to that is when you have the empty domain. On the empty domain, okay, let's take a look at this. On the empty domain, this is going to be true and this is going to be true. So that's the only case where they're not exclusive, okay? But basically, if you're dealing with a non-empty domain, then the relations these are mutually exclusive and mutually exhaustive categories. Let's look at a couple of examples so that you can see this. And in fact, actually, let's start by seeing if you can define an example of an irreflexive relation in ordinary English, like is taller than, is the same color as, is the mother of, you know, can you come up with an example in ordinary English of a relation which is irreflexive? Can you come up with an example in ordinary English of of a relation which is not irreflexive? And same thing for the non-reflexive case. Pause now. Okay, so hopefully you've had a chance to think about this, but notice that an irreflexive relation like is greater than from arithmetic, right? So, you know, if nothing is greater than itself. So let's suppose I've got the positive integers, right? You know, 1, 2, 3, 4, 5, or let's just suppose I've got the first 5 positive integers, 1, 2, 3, 4, and 5. Everything in that domain is such that it is not the case that it's greater than itself. And therefore, that's an example of an irreflexive relation. It has this formal property, okay? Is identical with, that is not irreflexive, right? So it's pardon me, right, is identical with, like if I've got 3 objects in my domain, A, B, and C, then, you know, it's going to satisfy this description. Everything is identical with itself, and therefore does not satisfy this description, and therefore is identical with, is not an irreflexive relation. Okay. Similarly, for the non-reflexive property, right, the loving relation is a good example. So sometimes things love themselves and sometimes things do not love themselves. At least one thing loves itself and at least one thing does not. So it satisfies this description. Okay. Moreover, you know, is the same color as. Well, again, we saw that everything is the same color as itself, right? So if I've got a thing with 5 objects in it, and some are blue, and some are orange, and some are red, right, and so on, they're all going to satisfy the description that it's for anything you pick out, it's the same color as itself, and therefore it will not satisfy this description. In particular, nothing in there will satisfy this description of there being at least one thing that's not the same color as itself. So is the same color as is not non-reflexive. So notice, just because you're not non-reflexive, it doesn't follow automatically that you're irreflexive. You could be either of these two, okay? Okay, let's pop on to the next video. I'll give you some more examples where you have to figure out whether a relation is reflexive, irreflexive, or non-reflexive. See you on the next one. That would be 4.11b.